Okay, here's our video on the GCF, the factor tree method. So we already have done the box way of getting the GCF. Well, now we'll do the factor tree method. And in order to do that, we need to know the prime factorizations, which we already went over in the last video. So what we're going to do is we're going to get the prime factorization of each number we're comparing. So let's look at 12 and 40. Now we can do this the box method, but we can also do it the tree method. You can just say the tree method or the factor tree method. So you get the prime factorization of each of these, and then we'll compare. So you already know how to do that, so see if you can get the prime factorization of 12 and then 40. Okay? So let's just move this over here. We'll do 12 first. And remember, when you're doing the factor tree method, you can use any numbers. You can do 4 times 3 or 6 times 2, whatever one you want to start. It doesn't matter. You'll get the same answer at the end. So we remember we circle the primes. 6 is not prime, it's composite. Okay, so there we have 12. Now let's do 40. And again, you can do any numbers you want. You can do 8 times 5 if you wanted. You can do 20 times 2. Doesn't matter, you'll get the same answer. Circle the primes. And then 8 is 2 times 2 times 2. Now you could have did 4 times 2 and just broke that down. So we have the prime factorization of 12 and 40. So I'm going to write it over again. We have it over here. Okay, so here's 12. It's 2 times 2 times 3. And 40 is 2 times 2 times 2 times 5. Now, we want to look for pairs or sets. Now, if you're comparing 3 numbers, which we'll do shortly, then they're not pairs, right? A pair is 2 things, but we can also say sets. So we're looking for pairs or sets. You see over here, we have a pair of 2's, and we have another pair of 2's. That's what they share. That's all they share. 2 pairs of 2. They don't share a 3, they don't share a 5, and this other 2, 40 has, but 12 doesn't have it. So 12 has 2 2's and 40 has 2 2's, so that's 2 pairs. Just think of like a sneaker. Okay, so if you saw these 2 pairs of sneakers, there's 2 pairs here. There's 4 sneakers, but there's 2 pairs. So think of pairs or sets. So we can make a pair box, or you can call it a set box. You don't have to do this. This is just to get used to it. Once you're used to it, you don't have to use this anymore. So in our pair box, we see we have 1 pair of 2. We'll just put 1 2 because there's just 1 pair that they're sharing. They share 1 2. They also share another 2. So we have 2, and in the pair box or set box, we always multiply. So we're going to get an answer of 4. 2 times 2 is 4. So let me go over that again. In the pair box or the set box, you're going to put down the numbers they share. They share a 2, so we'll put that down. They share another 2, we'll put that down. 2 times 2 is 4. Always multiply in the pair box. Now, we can check this with the box method. The box method, we just get all the factors, and you can see that the one factor that they both have in common is 4. That's what they both have in common. So the GCF is 4. The GCF equals 4. The greatest common factor is 4. So again, they shared a 2 because we made a pair. We made another pair because they share another 2, and 2 times 2 is 4. Now let's see if we can do 3 numbers. It's the same way. Find the GCF of 12, 18, and 50. If you get the prime factorization of each number, you can do this. Just remember, think of, instead of pairs now, just think of sets. The same thing. Make a set box. See what they share. So again, think of a set instead of a pair. So you should pause the tape and see if you can do this. Again, get the GCF of 12, 18, and 50. Okay, so I'll put 12 here, we'll put 18 here, and we'll put 50 here. So we can make our factor trees. And you can start with any numbers you want. 4 times 3. I can circle the 3. I could have done 6 times 2, right? And then we have 2 times 2. And there's our first one. So we already have 2 times 2 times 3. of 12. Now 18, we could do 9 times 2, circle the prime, 3 times 3. So now we have 2 times 3 times 3. Now, I left a space here because I'm trying to put the 3's together. You don't have to do this, though. Sometimes it's easier. Okay, now we're looking for the 50. And we could do 25 times 2. Circle the prime. Bring that over. And 25, we do 5 times 5. And now we'll just line up the numbers. I put spaces here because I don't want to put the 5's under the 3. So this was, bring this up, this was 12, and this was 18, and this was 50. So we can see that the only thing they share is a set of 2's. 12 and 18 have a set or a pair of 3's, but 50 doesn't have 3's. So they only share one set of 2's, one set. So in the set box, what we do here for the set box, erase this. So in our set box, we have one set, and it's a 2. And that's it. So the GCF equals 2 in our set box. And if we did it the box method, just to double check, right, you can see here's all the factors. And again, the only thing they share is 2. Right? The common mistake here is to say, okay, it's 2 times 2 times 2, it's 8. No, there's only one set that they're sharing. So the GCF will be 2. Okay, let's see if we can do another one with 3 numbers. This one's a little bit of a challenge. You should pause the tape and try to do this. Find a GCF of 20, 24, and 102. So pause the tape and see if you can do that. Okay, we can do the 20 first. Break down the 20. We can do 10 times 2. Circle a 2. Again, you could have used 5 times 4. Doesn't matter. Break down the 10. We get 5 times 2. And there's our first one. We have the prime factorization of 20. So I can put it here now. I can say 5 times 2 times 2. Now we could do 24. 24 we can do 6 times 4. Or we could have done 8 times 3. It may have been easier, because now we have to break down 6 and 4. So we have 3 times 2, and 4 we have 2 times 2. So now we have 2 times 2 times 2 times 3. Now we have to do 102. Okay, so let's do 102 over here. We'll do 102. And you can break down 102. You can do 51 times 2 if you wanted. And it stops there. They're both prime numbers. Okay, so bring it back over here. Now we have 51 times 2. So what is a set you can make that they all share? Well, they all share a set of 2's. And that's it. They don't share anything else. So the GCF, again, equals 2. It's not 8. Don't do 2 times 2 times 2. It's 2. That's the one set they share.